Decision-making is the cognitive process in which a particular course of action is selected from a set of alternatives. Effective decision-making involves forecasting the outcome of each option and weighing up the positive and negative aspects. Humans engage in decision-making every day. There are individual decision-making techniques.
Felix? Hey? $10 if you eat chili.
And there are group decision-making techniques.
Okay guys, who think Felix should eat this chili?
Some decisions, however, may be more complex. It may be hard to accurately assess the positives or negatives. The decision could also be an important one, and the decision maker needs to be confident that he or she has selected the truly best alternative.
Okay, Chong, our concrete batch requires at least 31% sand by volume for proper batching. Now, one source material, which has 25% sand and 75% coarse aggregate, sells for $3 per cubic metre. However, there is an alternative source that has 40% sand and 60% coarse aggregate and sells for $4.40 per cubic metre. Which do you think we should go for?
Clearly, for such decisions, a more structured approach is required. Now we are in the realms of decision analysis. Decision analysis is a discipline of approaching a problem with a set of potential solutions in a formal manner. It is an informative tool for the decision maker and is constantly utilized in industries such as business or engineering, where complex managerial problems are presented and the outcomes can have large economic, environmental, or social impacts. To illustrate the effectiveness of decision analysis, let's consider a common, everyday problem. Take Josh, who has just finished his homework for the evening. Josh has once again found himself in the classic situation where he is bored senseless, but has little to no motivation to do anything about it. The next hour is spent aimlessly walking from room to room and making half-hearted attempts at developing skills he always wished he had. After Josh's 17th visit to the fridge, from which he once again left empty-handed, he decides he needs to sort his life out, starting with what he does tonight. Talking to his friends on the telephone, it seems Josh has 3 alternatives. Alternative 1, go to town for a night out. Alternative 2, movie night with friends. Or alternative 3, stay in. Like most of his fellow engineering students, Josh is a social being and enjoys spending time with people. However, his social life is somewhat limited by financial constraints, and his motivation for activity fluctuates dramatically between so keen and This leads us to a subset of decision analysis that focus on problems where alternative solutions compete across multiple and often conflicting objectives. This area is called Multiple Criteria Decision Analysis, or MCDA. Josh finds himself incapable of making a choice and decides to implement the weighted sum method, the most widely known MCDA technique, to help him do so. The first thing Josh needs to do is quantify the performance of each of his alternatives across the 3 criteria of sociability, cost, and effort. Josh decides to use a point system to quantify sociability performance. For a given alternative, every friend Josh talks to on the night is plus 3 points. Every new friend Josh makes is plus 5 points. And every new attractive and single female friend Josh makes is plus 10 points. Josh anticipates that going to town would result in the talking to 10 friends, the making of 1 new friend, and the meeting of 1 new, attractive single female friend. This gives alternative 1 a sociability performance score of 45 points. For alternative 2, Josh knows 5 friends will be there, giving this option a sociability score of 15. If Josh stays in, he doesn't think he'll be talking to anyone tonight, and this alternative gets a sociability score of 0. Cost is irregular when it comes to multi-criteria decision analysis. For alternatives 1, 2 and 3, Josh expects he'll have to fork out $50, $5 and $0 respectively. Josh decides to quantify effort using calories burnt. With 5 minutes on the internet, he works out that disco dancing consumes an average of 280 calories an hour. On top of that, getting dressed, grooming and hairstyling consume 20 to 30 calories each. In the end, it seems town would require around 350 calories to be burnt, while a movie night or staying at home would burn effectively 0. He should, however, stay away from the popcorn. The next step required for the weighted sum model is to determine levels of importance, or weighting, for each criteria. This is used to build priorities and preferences into the model. When dealing with complex decisions in the industry, these criteria weights are often determined by reaching consensus amongst a group of experts and stakeholders in the project. These might be financial advisors, environmental engineers, health specialists, or representatives of the community. In the case of our friend Josh, appropriate weightings would depend on his current financial situation, his energy levels at the time, and any social obligations he felt he had. Let's say Josh was feeling a bit sociable and decided to allocate weights of 0.6, 0.2, and 0.2 to criteria 1, 2, and 3 respectively. It's important that criteria weights always add up to 1. Josh now has performance values for each of his 3 alternatives across his 3 criteria and his criteria weights in what's called a decision matrix. However, Josh notices that the units of measurement differ between criteria. If Josh wants to combine his performance scores, as required in the weighted sum model, he'll have to standardize each score. One way to do this is to use interval standardization. Here, the difference between each performance score and the set's least optimal score is divided by the difference between the most optimal score and the least optimal score. Care must be taken to consider the signs of the set. This will give him a new set of performance scores that retain their relative strengths but are dimensionless and can therefore be added together. Josh can now use the weighted sum model to determine which activity he should do tonight. For each alternative, Josh takes his performance values, multiplies them by their corresponding criteria's weight, and sums them all up. This provides Josh with a final value for each alternative. As you can see, Josh should go to town and party. While Josh pops off to get ready, we can revisit his criteria weights to try and gain an understanding of how much they affect the final alternative values. We could pretend that our friend Josh is a bit of an introvert and rarely fancies the idea of putting his dancing shoes on. We can see how this change in criteria importance, or weighting, propagates through the model and influences the final results. These now suggest that he should stay in. On the other hand, Josh could be a social butterfly, but have next to no money in his wallet. Maybe a movie night would have suited Josh better in this parallel universe. As we have seen, decision analysis enables us to make better informed decisions based on a quantitative assessment of our options. For Josh, his indecisive Fridays are now a thing of the past. For us engineers, the same techniques can be applied to less trivial problems. The construction of a new highway, for instance, would have huge implications at an environmental, economical, and social level. Likewise, the design of community spaces or the expansion of a sports stadium requires careful and formalized consideration. Decision analysis gives us the support that we need to make critical decisions and give instruction to others.